All right, we're on to section 11.2, exponential functions. And they've been talking a lot about exponential functions with the coronavirus and all this kind of stuff. So you may have seen some graphs. But you are going to learn them firsthand right now. So just to refresh your memory, a function, remember, is something where each x value is connected to only one y value. And one way we used to test was we had that vertical line test. Remember, you could draw a vertical line, and if it only hits the graph in one place, that means that, yes, it is a function. But how do you know an exponential function? By looking at it. We had talked about quadratic functions last in chapter 9, and remember, we knew it was quadratic because there was what in it? An x squared. That's correct. Well, this one has the x in the exponent, so it looks something like this. Where, of course, the f of x is our y. Turn that right side up there. Yeah, so whenever you see the x in the exponent there, that's going to be your clue that you're working with an exponential. So we're going to do three things today. We're going to learn to first evaluate a function. So that basically means I'm giving you the numbers and you're just learning how to work with this data, because you got to do exponents first and then multiply by the a. You're then going to be able to identify it by taking a bunch of points or coordinates and be able to examine them like we did with linear and quadratic to see if it's exponential. And then you're going to learn to graph it. And today you're going to learn to graph it just using simple XY charts. So the things we're doing aren't new, they're just new with this function. All right, so let's start here with example 1. The function f of x equals 500 times 1.035 raised to the x power. Models the amount of money in a certificate of deposit after x years. So a certificate of deposit you'll sometimes hear of as COD. You get those at the bank, and it's a way of investing your money. Depending on where the economy is, it may or may not be a wise choice. Anywho, how much money will there be in 6 years? Okay, so 6 is your x value. So we're going to look for what is f of 6. Okay, so we have the 500, that's the same, and the 1.035 raised to the 6th power. So again, I'm going to show you on the calculator. And I'll slide that over so I can have both here. And last lesson I showed you where that power was. So remember, you always want to do your exponents first. You do not want to multiply these first. So I'm going to do 1.035. And we had that, I have the y to the x button right there. Right there. You're going to want to find yours. And I'm going to raise it to the 6th power. Push equal, and I get that number. Then multiply it by 500. And this is money we're talking about. So it's $614, and let's round it to the nearest cent, which is the second place. So $614.63. Whoops, whoa, what am I writing? $614.63. There we go, that's better. All right, so that was the first thing. That was how to evaluate a function. We're just basically learning how to substitute numbers in and figure it out. Now we're going to do the second one, the identify. So here are two sets of data points, and we're going to line them up like we always have. So we put 0, 4, 1, 12, and we put them vertically. Okay, and we're going to check the left side. This has always been consistent. It's always a constant change. So that's all, we're all set over there. Now, if we were going to do and check for a quadratic, or if we were going to check for a linear, we'd be looking for the difference, wouldn't we? Well, in an exponential, it's a geometric sequence, so we are looking for multiplication here. So it is going to be, it gets multiplied by 3, doesn't it? 4 times 3 is 12. Does it work here? 12 times 3 is 36. Yep, it does. And 36 times 3 is 108. So my answer to this is yes. It does, these ordered pairs do satisfy an exponential function. And so y is the x value change is constant, because it says to tell y. Actually, it doesn't say, but I'm going to tell you why anyway. And the y value multiplies by a constant amount. So I hope you're seeing the difference between what we did in the past and now. Here it was a difference, adding. Here it's multiplying. Okay, let's check these out. All right, -1, -64, 0, 0, 164, and 2, 128. Do a quick check on the left side. +1, +1, +1. Okay, we're all set there. Now, how about here? What would I multiply this by to get this? 0. When I multiply this by 0, do I get 64? No. It's not going to work, because that already we are thrown off. There's not a value that you can multiply both of them by a same value. Okay. So now let's go, back to this, to the third piece, our graphing. Yay! So I have these lovely little graphs here, which I put on the page for you. And I'm going to go ahead and do an XY chart. You know how I typically say it's good to start with certain values when you're doing this? And in general, okay, now when I say in general, it means most of the time with what you're working with. You may need to do more or less, or not less, but more to figure out your own graph. But for this one, these numbers typically are pretty good numbers to select. Again, you may need to do more. You may need to do 3 or 4 or -2, but those are good starters. And remember, we're picking the x's, but now we got to plug them into our value here and find out what our y's are. So I'm going to go ahead and do my work right next to the problem. So I have y equals 0.5, 2 raised to the x, which in this case is a -1. Well, this is good for you guys to remember with a negative power. First of all, the 0.5 doesn't go anywhere. Actually, I'm going to write that as 1/2, because 0.5 is a half. And I am, because I'm seeing what's coming. To make this a positive, remember you have to do the reciprocal of what's inside. And that's a 2/1. So you just throw it downstairs. And now I get that. Okay, so 1/2 times 1/2. Remember when you multiply fractions, 1 times 1 is 1, and 2 times 2 is 4. So there is the first coordinate. Let's do the next one. Y equals 0.5. I don't want to keep doing that. 1/2 times 2 raised to the 0 power. Anything, remember, raised to a 0 power is 1. So my answer is 1/2. Now I'm going to do the 1. So I'm going to leave it as 1/2 times 2 raised to the first power. Anything to the first power is itself. So I have 1/2 times 2, which I'm going to write as 2/1. And that is equal to 2/2, which is 1. And lastly, I have 1/2 times 2 raised to the second power. So I'm going to have 1/2 times 2 to the second is 2 times 2, which is 4/1. And I get 4/2, which is 2. Now I could have cross-canceled here, divided them each by a 2. That would have been fine. They're small enough numbers, it didn't, whatever, it doesn't matter either way. 4 and 2. Now we need to graph those. When you go over to these graphs, I highly recommend you don't use the real small ones as ones. I'm actually going to darken these in so you can see. I'm using those as my one unit markers there, so that we can see them a little more clearly. Okay, so let's go ahead, because remember over here, this is my coordinate, -1 and 1/4. That's my first coordinate. 0 and 1/2 is my next. 1, 1, and 2, 2. -1 and 1/4. Well, this is 1/2, so I'm going to go halfway up there and put a dot. They get pretty close to the line. Exponentials, as you can see by looking in your book, are curves that approach the line but never hit the line. And the next one was 0, 1/2, so 0 and up 1/2. And the next one is 1, 1. And the next one is 2, 2. And it's going to approach down here, and it's going to veer up. And that's what an exponential graph looks like. It's a curve, but notice it doesn't hit the line. All right, excuse me. Let's hit this one up. X, Y. Again, I'm going to start with those same values that we did before. And I'm going to start plugging in so we can keep moving here. Y equals a -1/4 times 2 to the -1. Again, the -1/4 stays. When it's raised to a negative power, this gets flipped. It's put in the bottom. And I multiply across the top. Negative times a positive is a negative. 1 times 1 is 1, and 4 times 2 is 8. All right, so I've got -1/4 times 2 raised to the 0 now. Remember, anything to the 0 power is 1. -1/4 times 1 is -1/4. Y equals -1/4 times 2 raised to the first power. So I get a -1/4 times 2. I'm going to put it over 1 so I can see those fractions clearly. You can cross cancel if you'd like, and you get a -1/2 because you can divide those each by 2. And lastly, y equals a -1/4 times 2 raised to the second power equals -1/4, and this is 2 to the second is 4, and I'm going to put it as a fraction, so again I can see these. I can divide them both by 4, and I'm left with a -1. So that is my work. So don't skimp on your work because you make some small mistakes when you do. Just write it out. All right, so again I'm going to darken these in so we can see them super clear. I suggest using graph paper and not making your own graphs. It's really just makes everything more difficult, to be honest. -1 and -1/8. It's right below the line, almost on the line, isn't it? 0, -1/4. 1, -1/2. 2, -1. We can see where we're heading here, but I'm going to do one more because I just want it real clear. Y equals -1/4 times 2 to the third equals -1/4 times 2 times 2 is 4 times 2 is 8, and that equals a -2. So 3, -2. 1, 2, 3. There we go. That just helps a little bit here. I'm going to go ahead and curve. And it approaches the line but never hits the line. Aren't those pretty? Love these. Okay, now the other graphs here, we got a couple more, and then I want to show you some similarities between them. So X, Y, you notice they're a little different. In both of these were, that was 2 and that was 2. Right? So in both of these, this number was greater than 1. Okay. And then this number was greater than 0, but this number was less than 0. Okay, so look at the difference in the graphs. When this stayed the same, when it was a positive, it went up, and when it was a negative in front, it went down. That kind of falls through with what we have in general learned about parabolas too. All right, well, let's take a look at this. So look at here, we got a negative and a positive here. Both of these are small numbers though. They're both between 0 and 1. So let's see what happens with that. All right, so negative 1, 0, 1, and 2. Go over to this one too. Negative 1, 0, 1, and 2. So, I'm doing my work down here, a little more scrunched on room here. Y equals negative 1 times a fourth raised to the negative 1 power. So that equals a negative 1. In order to get this positive, I flip this. Times 4 over 1, that equals a negative 4. Y equals negative 1 times 1/4 raised to the 0. Negative 1, anything to the 0 is 1. I get a negative 1. So some of these turn out pretty nice. Then we get to these that get a little sticky. 1/4 raised to the 1 equals negative 1 times a fourth, which is negative 1/4. Going a little faster here. Y equals a negative 1 times 1/4 to the second equals a negative 1 times a fourth times a fourth. 1 times 1 is 1. 4 times 4 is 16. So I get a negative 1/16. All right. No, I'm doing. So next we're going to do, sorry about that, had my son trying to get in his room, my youngest. So we're going to go ahead and graph this. So we are going to mark these again. So as you get these smaller ones that near the axis, x-axis, don't worry about, you can hardly be super close when you're talking about 1/16, right? But these are negative 1, negative 4. We're down here. 0, negative 1, 1, negative a fourth, and then 2 real close. So it's curving like that. And over here, I am going to change this because I like to see this as a fraction. So I look at that and I say that's 6/10, which reduces to 3/5. So I am going to use this as 3/5 because I would much rather use that when I'm figuring these out. So y equals 4 times 3/5 raised to the negative 1. That's 4 times, flip this over, 5/3, put that over 1. We get 20/3. 3 goes into 20 how many times? 6, 18 with 2 left over, so 6 2/3. All right, y equals 4 times 3/5 raised to the 0. That's 4 times 1, which is 4. And then y equals 4 times 3/5 to the 1 equals 4 times 3/5, which is 12/5. 5 goes into 12 2 times with 2 left over. And 2, y equals 4 times 3/5 to the second power is 4 over 1 times 3/5 squared. So that would be 3 times 3 is 9. 5 times 5 is 25. 4 times 9 is 36 over 25. 25 goes into 36 one time with 11 left over. So 1 and 11 25ths. Okay, so let's check it out. All right, so negative 1 and 6, whoa, we're off the charts here. Negative 1, and here's 5, and 6 is about up here. And 0, 4, and 1, 2, and 2/5, that's about half, so that's about right there. And then 2 and 1, 1 and it's almost a half. It's right there. So we can kind of see where we're heading. We're heading down. Like that. So that's interesting. So when we look at these, when this was smaller, here, let's flip it over. I'm going to go back to the original page. Can you flip your page back? I'm just going to give you a general layout of these graphs. Okay, so where did I put my other page? Right here. All right, let's put a general thing for your graphs right here. Put two charts right here. Okay, two XY charts. And when this one is going to be when the b is greater than 0. And this is going to be when the b is, why did I put a capital B, I wonder? These are small b's, are less than 1. Okay, so it's either going to be greater than 0 or it's going to be in between 0 and 1. That's the only option. And then up here, I'll put the difference in the a's, the number in the front. Because it's going to take a little bit to learn this. It's going to look like that if the a is greater than 0. And it's going to look like that when the a is less than 0. And now when we're talking about this b number in the parentheses, the ones we just did that were fractions in between 0 and 1, it's going to look like this if a is greater than 0. And it's going to look like this if a is less than 0. So you can kind of take a look at some of the similarities or differences. If the a is less than 0, if it's a negative, notice that these are both always under the x-axis. If this is a positive number, it's greater than 0, it's going to be above the x-axis. Now how it turns depends on this one. Okay? All right. So that's all I got for you today. It's kind of a lot. Use this as a key. I hope you took good notes. Otherwise, you can always refer back to it if you forgot something. Take care. Have a great day. God bless.